Hello, everyone. This is LEGO Dark Space, a technical deep dive into innovation. Today, we're stepping into the wild corners of UEFN and exploring how we genuinely took this platform to its breaking point to craft something totally new for LEGO. I'm talking not just a game, but a showcase of mechanics, UGC capabilities available for everybody, and a design theme that redefines how LEGO can be experienced. Now, look, I could stand here and start off with specs and all that boring stuff, but I'd rather start by showing you guys the magic we've cooked up in LEGO Dark Space. And luckily, I brought some help. I said, luckily, I brought some help. Brick, come on, we practiced this like a bunch of times in rehearsals. Oh, there you are. Yep, perks of working with the LEGO group. They left this little guy behind. And, well, he's my digital assistant now. So this is Brick, and he's here to keep us rolling. Well, actually, I'm pretty sure he's just to make sure I don't crash the whole presentation. But don't let the clumsiness fool you. He's actually pretty cool. So let's start with a peek at LEGO Dark Space. Brick, you ready? It's all yours. All right, so that's a very short introduction to what is LEGO Dark Space. It's a space horror game we launched in partnership with the LEGO Group in Fortnite last October 2024. You're a minifigure stranded in an abandoned space station with just a flickering flashlight to guide you. Your job is to weave through dark corridors, dodge monsters as you hear your heart rate increase, and crack light-themed minigames to escape. It's got cinematics that set the tone, a backstory packed with mystery, and a spooky LEGO vibe that's still very playful at its core. So what makes LEGO Dark Space so special? Well, it's the very first LEGO horror game in Fortnite. A proof of concept that UEFN can actually handle wild ideas. Horror isn't off limits with LEGO, but it just takes on a different tone. But that's what we do, not just with brands, but with UEFN as a tool itself. And it wasn't just about spooking the players. It was also about inspiring creators about what's possible. And today, we won't stop at LEGO Dark Space because we'll crack open the tech, random layouts, lighting hacks, custom NPCs, and then spin it into a fresh example. Now, these aren't one-trick ponies. They're keys to unlocking your next big thing. So there's a few things we had to analyze first, like how can we make LEGO a brand that is so light, dark? Okay, a tumbleweed, really, Brick? Okay, let me reword this. So, how can you make something fun also scary? For that, there's 4 key factors. The first one is cinematics to set the mood, which you've all seen. Secondly, the lighting and the flashlight mechanic. And we wanted to make sure the lighting looked perfect on every platform, something we'll later deep dive a little bit more into when analyzing all of the technical innovations. Mix that with monsters chasing you and limited lives. And finally, a thrilling backstory with hidden logs that mix in with an amazing marketing campaign. All right, so we've set the stage with LEGO Dark Space. But before you build anything, you've got to know who's going to be playing, or who do you, as a developer, want to target. So let's talk about engaging a diverse audience a little bit. How do you take a horror game and make it click for the right players? So that's what we tackled with LEGO Dark Space, and it starts with one big question. Who are we building this for? Brick, any guesses? Everyone, well, you're not wrong, but that's also kinda wrong. You can't just throw a game out there and hope that it sticks. That's why identifying your target audience is step 1. It's the foundation of everything. First, why is this even important? Simple. Your target audience is your compass. Mess it up and it's like you're building a roller coaster for people who hate heights. Now, one of the LEGO Group's promises is about play well, fun, safe, and inspiring experience. But LEGO Dark Space, well, we're in space. Monsters are roaring, lights are flickering. So knowing our target audience lets us tailor the scares, the humor, and the goals so that it hits just right. Okay, with that figured out, we wanted to narrow it down even more. This is where Fortnite's platform excels. We used it to analyze what makes games engaging to millions of players, from the very casuals to the pros. The LEGO Group and us, we launched LEGO Dark Space as a variety game to stand out and to bring something brand new to the table. So how do you align all of this with your goals? Well, like I said, start with the audience and then build backwards. Our scope was simple. It was a replayable horror game, solo or co-op, light-themed and expandable. Now, kids, they needed puzzles, so we designed, for example, Reflect a Light Beam. Teens, on the other hand, well, they wanted stakes, so what was the solution? Randomized layouts and monster chases. But then you want to appeal to the adults as well, who've seen all of this before. They crave depth and emotional storytelling. And that's where our logbooks and, well, the Secret Monolith story delivered. And that's the trick. Know your players, tailor the experience, use the platform. LEGO Dark Space wasn't just a game, it was a bridge to LEGO's diverse crowd, with scares and laughs for everybody. And now finally, before we start jumping into the technical part, let's quickly touch on the Monolith, a crazy multiverse marketing stunt by the LEGO Group that took the community by storm. Okay, so for the younger players, this Monolith, it was simply the villain of the game, right? And that's usually how they see it. And in a lot of times, you can get away with that. But what about when you want to circumvent expectations and transform your classic villain into a creepy riddle? This is how the Monolith transformed the launch of LEGO Dark Space into a true marketing phenomenon. Now, this was about more than a game. It was about story, it was about buzz and community. Brick, care to explain who the Monolith is to these guys? Oh, okay. Anyway, I'll do it myself then. Well, this monster popped up in October 2024 across 3 different LEGO experiences: Parkour World, Chases vs. Hunters, and Monsters Fishing. And players had no idea it was teasing the launch of LEGO Dark Space debut the whole time. Like I said, they saw it as just the Halloween villain and nothing more. Exactly like the LEGO Group were intending. But in reality, the Monolith, it was our glue to linking it all together. All maps connected through the Monolith. Things really went into second gear when the LEGO Group's marketing team called upon 4 Fortnite creators: Cypher PK, Lachlan, Loserfruit, and Ali A. They got real-life shipments labeled "Do Not Open," with little monoliths inside, and a cryptic teaser. What's the worst that can happen, right? Or so they thought. Players started cracking the side quests in those islands for a code, and it unlocked the secrets in LEGO Dark Space's room, in which they could find the 4 influencers trapped. By using their knowledge from the previous LEGO games, they could now unlock secrets in ours. The final piece of the puzzle is in this room with the influencers was a call to action with one simple question: who will you save? Social media loved it. X, or Twitter as we're all calling it, let's be honest. They went wild, it lit up, until one creator emerged. And to propel engagement even further, participants got a free LEGO building set for their Fortnite locker. Now, when the results were revealed, they got to watch all 4 creators play together in one single lobby on stream, adding an edge of competitiveness as to who would win. Everyone was rushing to make sure their favorite would be saved. Meanwhile, Reddit got wild, because the LEGO Group asked them for their funniest credits, and fans truly delivered. We patched them in-game with a custom credit roll, and in fashion with every single piece of media content in 2025, a classic post-credit scene. Rick, are you okay? This was your cue. Oh, there you are. You look a little bit different. Can you still play the video? Yeah? Appreciate it. Now, you might ask yourself, okay, cool, but why bother? People see marketing as just a way to gain reach, impressions, spread the word, you know? But when you do marketing differently, with a way that fans can actually engage with your product, it creates more than reach. It creates a connection. The monolith linked experiences, it sparked talk. Twitter posts hit the thousands. What is this thing? Influencers, voting, Reddit's help. And it built a community that spread LEGO Dark Space wide. Streamers peaked. Players started sharing their codes, they strategized escape methods, and they competed for the best times. People raved. And it's proof. A game is only half the battle. Story and buzz, that's what makes it soar. But now, Brick, it's time to get technical. I hope you were up last night studying for this. Now that we've covered the monolith and how it sparked buzz, let's look under the hood of this thing. This is the tech that makes LEGO Dark Space tick. First up, randomizing the map and minigames. Every playthrough of LEGO Dark Space feels different. Sometimes the Simon Says minigame with the laboratory is in the first room on the left, and other times it's somewhere else completely. This keeps players guessing, which is key for replayability. So, how did we do it? Let's figure it out together. Oh, Brick, you don't need help. You've been through this before. Want to make a first guess? Great idea. Data layers. Okay, let's explore that. So, what are data layers? Well, in UEFN, data layers lets you organize actors into different layers that can be loaded or unloaded. It's like toggling your beard on and off in Photoshop. Basically, you can have multiple maps or areas that only use memory when they appear, when they're loaded. This is an amazing tool for managing complex levels, like switching a map from summer to winter, or showing a castle's destruction before and after battle. You can create unique gameplay experiences by toggling on and off these layers. Which will work it, or will it work for randomized layouts? Well, let's imagine setting up a different layout on separate data layers. One layer has Simon Says in the left room, another one has it somewhere else completely. And then at the start of the game, we pick a random layer. So, does it work for LEGO Dark Space? Well, sorta. We can create different data layers, but UEFN only lets you enable, well, one at a time because otherwise they would overlap. So a randomization, it would be very limited. The layouts would have to affect the whole map and not just one room. And we needed a little bit more flexibility. So let's try a different idea. Okay, what about sequences? Okay, some of you are getting excited. Some of you are about to leave the room. I get it. Don't worry. Sequences in UEFN can manipulate objects, even entire rooms. So the idea is to design each room, like Simon Says, with its lab setup, somewhere out of sight, right? And with these rooms created separately, we now create a sequence to move room A to target location 1 in a single frame. Exactly, you know, like this. And then we'd keep the state so that room A stays in location 1. Then we'd have to make another sequence for location 2 and another for location 3. And at the start, we pick a random sequence to play it, and voila, room A is in a random spot. Sounds good, right? Well, not quite, because we need 10 sequences for room A if we have 10 possible target locations, 10 more for room B, 10 more for room C, and, well, you get the idea. It's not scalable at all. Plus, moving rooms with sequences can mess with nav mesh net generation, leaving the monster stuck, and don't even get me started on join in progress. So, yes, it could work in theory, but in reality, it's not practical. So, I'm glad everybody's sitting back down again. Now, which brings us to our final solution, verse, my favorite. The logic is similar to sequences, and there's a lot we can learn from our previous idea, but with way more flexibility. We create target locations, which are just empty slots on the map, and we mark them as spawn points. Then we use verse to randomly assign a room to each one of these slots at the start of the game. It's scalable, it's efficient, and it solves the nav mesh and join in progress issues because verse runs on the server side. To show you, let's look at a simple example that we'll create together. A magical door feature you can build with this trick. Players walk through the door, and they think they get transported seamlessly to a completely different area. Now, don't worry, it's actually a lot simpler than it looks, and we'll quickly work it out together in UEFN. First, we need to create our rooms. The idea is simple. Each room, like the Simon Says lab, will be a child of just one single blueprint prop. So we can move it as just one whole unit. So let's start by creating an empty blueprint prop. This will be our base prop. And just select the building prop parent class, and then drag it into the viewport. Now let's build our first room as a child of this blueprint. I'll add some basic geometry, like a floor, walls, and a few props to make it feel like a sci-fi lab for the Simon Says. This is all done with assets available to everybody straight from the content browser. Now, I was going to time-lapse me building it, but this timer here is staring at me, so ta-da! Here's a one-frame time-lapse playing on repeat. Great, so we've got our first room, a sci-fi lab. Now let's make a second one, but something a little bit different this time. We'll add some nature elements to it to make it feel like a whole world inside. Same steps, add an empty blueprint to the map, drop in a few plants, rocks, and boom. Now that you get the idea, let's do it one more time to get an extra room. I'm just going to add one single prop for the sake of the demo. So you can see we have our blueprint prop, we have, well, a floor piece and a lab setup. All right, great, nice one, Brick. So we've got 3 rooms, a sci-fi lab, a cosmic void, let's call it, and a nature oasis. Finally, we need a target location. So let's add one more blueprint prop right here outside. So we just add it, we call it target prop blueprint, so that we know where to teleport our rooms to. Now let's jump into the verse. Now don't worry, I'll share everything after. So first, we create a new verse file. I'll call it teleport device. And we start with our editables. What do we need? Well, to keep it modular, we'll use an array of creative props. This lets us add or remove rooms as we want to, without ever needing to touch the code again. So you can scale it up from 3 rooms to 50 rooms with just a few clicks. You could also use verse tags to make it even more manageable, but let's just stick to the editables for the sake of the demo. And then we also need our single target location, which is the last blueprint that we set. And finally, a mutator to activate it all. Next, we create a function to teleport to rooms. It will take 2 arguments, our origin prop, which is the room that we're going to move, and our target location, which is where we want it. In this function, we get the transform of our target location's blueprint, and then we're going to teleport the original prop right there. Now, since all of the room's assets, including design, but also the mechanics, are all children of that one prop, they'll just move together in a single frame. Now, let's copy this function just to create a reset option. We'll call it move prop out. Now, this time, we want to make it a little bit more dynamic during gameplay so that it can move a room back outside of the view to a hidden location after the player leaves. Finally, we just need to set up our mutator zone to trigger this all. The zone will cover the room right up until the door. We'll bind it to the editable to link it to our verse device, and write a function for when a player enters. This function is simple. When a player walks in, it activates. We set up a subscription with agent entered event, we roll a random number, pick a random room from our array using that number, and then we call this teleport function that we just wrote using our blueprint's origin prop that we just picked from the array and our target location. Now, when the player leaves, we do the exact same, what we call our reset function, just to move it back out of sight. And then finally, we just need to set up the bindings. Now, let's test it. We spawn in, run into the next room, and look, we're in the sci-fi lab. Run out, back into the mutator zone, and boom, we're in the single prop cosmic void. And now run back out, and boom, we're in the nature cosmetic, whatever you want to call it. Nice one, Brig. That wraps up our first implementation. You know what to do. Mic drop it. Nice one. All right, so magical door, insert check mark emoji here. I mean, check. Now, you can easily scale this by adding more origin rooms, more target location rooms, or anything else you can imagine. And the best part is, NavMesh is fully generated at runtime on all of these props, so the monsters will perfectly navigate between all of the obstacles. Next up, let's talk about how we created the fully dynamic map in LEGO Dark Space. This map, it does a lot. It tracks your minigame progress, it shows you where to find them, marks player blips, gives you clues how to unlock the monolith secrets, and updates all of this on the map by itself as you play. Now, what makes it special is that the technique that we use, it can be used for so much more. You can use it to create a custom inventory, to create a power-up selector, or even an item shop. Oh, hey, Brick. Oh, well, you're already giving it away a little bit what we're going to do, because it hints at what's coming. But before we dive into the magic, let's start with brainstorming a simpler approach. So what would be the basic way? Well, you use a map controller in UEFN, and you take a custom texture, like a map image of LEGO Dark Space, right? You set it all up in the map controller, and then you add map indicator devices to mark objectives, like a minigame location, for example. Then when you complete a minigame, you disable its indicator, and you're done, right? It could work, but it's limited, because those map indicators, they show up as default badges. They look a little bit rough, even if you use custom materials. And want to add things like a custom player blip, for example, well, not really an option. Show monsters on the map? Nope. And we needed more control, so we scrapped that idea and went for something better. So let's jump into the magical method, and I'll explain it first, and then we'll deep dive and dig into it together. Oh man, Brick, you're full of spoilers today, but you're right. The core idea is this. We set up a custom camera that looks at a plane with our image. But here's the twist. This method isn't just for maps. It can power all sorts of features. So to show you, let's build a little item shop together. And no, this won't have skibbity toilet bag blinks. Or maybe. Anyway, the principle is the same. We'll have a camera look at a fancy backdrop, like a shop counter or some cool material, hidden outside of the map. Then when a player opens the shop, we add Verse UI for interaction, and we spawn preview items in front of the camera, like tools or effects. So here's how we've done it in UEFN. First, we create a sequence. Let's add a camera that looks at our backdrop, tucked away somewhere that players won't see it, like way above or below the map, anywhere that's outside of view. Now we'll link it to a cinematic sequence device. We set the visibility to instigator only, so only the player who opens the shop sees it. And we use the loop playback to keep the camera view active. Step 2. We add an input trigger device to open and close the shop. We could use, for example, the custom 12 input, which is the harvesting tool, since it's one of the few free options we have until custom mapping arrives. Or if you only want players to open the shop at a specific location, just a normal button. Now for the verse part. Now once again, we will share all of the code snippets after the session, so don't worry about the nitty-gritty. We'll focus on the key pieces here. First, we create a function to open the shop, bound to our button. Now, in this function, all we do is play the sequence for the instigating player. Easy. For now, let's also only work on opening the shop and just forget about the fact that we also want to use this, system to close the shop. I think some developers would probably even prefer it if you can never leave their store. So anyway, now we add Verse UI. Now there's plenty of documentation on this, but basically, you create canvas slots with buttons, and you can make them as fancy as you like. I'm just going to use text here for the sake of our demo and for showing the true magic of it all. But I highly encourage you to polish this as much as we did in LEGO Dark Space. Next up, we'll bind a function to each button. Now here's the cool part. Each function just teleports a prop into the camera's view. Click the first one, and a hat appears. Click the second one, and it's a wand that teleports in, and so on. So let's work this out a little bit more. Quickly back out of Verse into UEFN to grab the location we want to teleport our items to. Oh, hey Brick, didn't forget about you. I'll feed you later, but that being said, thanks for letting me copy your location. So let's add in all our item shop props as well. We'll use just, again, an empty blueprint prop so we can teleport a lot easier. And now back to Verse. We'll need an editable for each creative prop so we can teleport them. Now, I split them up here. You can put them in an array and make this a lot more fancy. And then we press the first button. When we press this, we teleport this first item to the exact correct location that we want to. We'll also need a clear function to move all the props back out of sight so that they don't overlap with each other when cycling through different items. So let's call this function before we teleport a new function in, or a new prop in. So this code, it might not be the most optimized at all, but it gets the point across. Actually, remember the function from before? We could use that as well, refactor it, and reuse the same function for teleporting props in and out. Finally, let's set up the bindings. Now, it's the most tedious part, but it's very straightforward. Now for the nerve-wracking part. It's time to test this out in game. I know, terrifying sentence. So we've got our camera, we've got our backdrop, we've got our props, and a crash report. I'm kidding, I've never had one of these before. I even had to grab this one off the internet. We press our button, and boom, the camera snaps to the shop. Verse UI pops in, clicking the first button, and our custom purchasable hat appears. Click the next one, and the next item shop just pops in. Smooth. Now back to how this works in LEGO Dark Space and how this item shop system is very similar. We use the same method. A camera looks at a plane with a map texture. But instead of shop items, well, we teleport icons onto the plane. Player blips, minigame markers, monster tokens, even monolith clues. All of these update live. Complete a minigame, and its marker just disappears. Move through the map, your blip, it shifts with you. It's dynamic, it's customizable, and it opens up endless possibilities. Now, here's where things get really cool. The last technical challenge from LEGO Dark Space that we're deep diving into today. How to create custom NPCs. Now, in our map, these monsters, they roam the dark halls. They're chasing you with the heartbeats that you can hear. But here's the catch. UEFN, well, it pretty much throws a tantrum if you try to change the cosmetic modifier of a LEGO NPC spawner. But we found a way around that, and we'll show you how by building a small pet system together. Maybe not that kind of pets. Let's do something else. What about a pet's brick? Well, no, I don't want two of him. I can't handle that. Okay, how about a monster guardian pet? Brick, you in? Yeah? All right, I guess that's a yes. First, let's brainstorm together like we did before. Just the obvious starting point is obviously verse. It's our go-to for most custom behavior in UEFN. So imagine an asset like a pet, and it follows the players. We could write a verse loop that moves it to the player's current location with the move to function. It's the standard solution that you'll find online when looking for UEFN pet systems, right? So how does it work? Well, it's just a loop, and it keeps the pets close to the players. And in theory, it could work, yes, but there's a problem. This approach, well, it ignores nav mesh. The NPCs would act like ghosts, moving directly to the player, even phasing through walls. And if the player runs behind a corner, well, and the NPC, it just floats through the wall. It's great if you're trying to make a ghost, but not for enemies in LEGO Dark Space, especially with our dynamic layouts. So monsters, well, they had to navigate properly. So if we want real nav mesh navigation, there's only one way to do it. Using the NPC spawner. There's no way around it. So we'll split this up in two parts. First, we'll just set up the basic NPC spawner as a guardian pet system using the default cosmetic, and then we'll reveal the trick as to how to customize its look. So let's jump back into UEFN and add an NPC spawner to our map. Now, we don't want the default behavior. We need something more custom. So go to the Verse Explorer, right-click, and create a new verse file. And then select the NPC behavior basic. But if you're familiar with Verse, I highly recommend checking out the non-basic version because it actually has some really interesting code. But for simplicity, let's stick with the basic one. Now, I'm already going to break my first rule, and we're going to grab this tiny piece of code from the non-basic file because it just makes our life a lot easier. It's just a few variables that save the result of some functions that we're going to use, and we'll paste this if statement right here in our basic file. And it pretty much, well, it helps us check if the NPC is found with deciding variables. Now, all of our codes, or most of it, we're going to write in the then block. So it only runs if the NPC actually exists and it's found. So, first issue already. We need to get the player because we need to know where the NPC needs to go. We want the NPC to follow them. Now, normally, basic, you use the play space, you use the get players, a function we've almost all seen. But here's the first catch. In an NPC behavior script, play space isn't directly available, so we have to do a little bit of abstraction. So we just create a separate verse file, helper functions, and in it we write a quick function that says return all players. It gets the play space, call get players, and just return this array of players. Now back into our NPC behavior file, we add a variable to use this. So we just make a reference to the helper functions, and then before our if statement, we call this function to get all of the players. Then inside of our if statement, we grab the first player and save it into a variable. And while we're at it, let's also save their parsed Fortnite character, all nicely grouped up together so we know everything exists. Whew, that was the heavy lifting. Now in the then block, we create a loop to make the NPC follow the player. So let's write our loop. First, we get the player's location with the get transform, and then create a navigation target to that location. We save that in a variable, and we call the navigate to send the NPC right there to that variable. And boom, it's that easy. Now, finally, let's also add an optional movement type parameter when we call this function so that the NPC runs. Because, well, we're running out of time. Now, please don't bring out the tumbleweed again. I know only half of these jokes are gonna land. So once it arrives, we wait 0.1 seconds before the loop runs again, just for performance reasons. And that's our basic NPC behavior. It uses nav mesh for proper navigation, so no more ghosting through the walls. And let's test it very quickly together. So I can either just take my NPC spawner and set the NPC behavior script to our verse script that we just wrote. Or you can actually just drag the verse file directly into it, and it will create a new NPC spawner for us. And finally, we're going to do the magic of making it a custom monster instead. So this here works like a charm. So let's reveal the magic of how we've done this, because, well, that's what you guys want to see. So we have our Guardian pet system working. The NPC follows the player using proper nav mesh. But now we want to make it look like one of Dark Space's monsters, but not just the default NPC. Like I said before, normally trying to change the cosmetic modifier will cause UEFN pretty much to pee its pants. So how do we do it? Well, it's actually a lot easier than you think. So let's go back to our original way of thinking of using verse to move stuff. And what we'll do is we're just going to add a skeletal mesh with a running animation. It could be anything, even weird shapes, a spider, a dog, or in our case, a monster minifigure. And as always, we start by adding it as a child of an empty blueprint prop hiding somewhere outside of the map so we can teleport it around easier. But now, how do we replace our Guardian NPC with this monster mesh or Peely or whatever you want? We don't. We're going to cheat it in. So let's go back to our verse file, and we'll jump into the then block of our onBegin function, right after the NPC spawns. And now we're going to run this asynchronous function, which means it just runs on the side. First thing we're going to do is hide the NPC by calling the character.hide. So now we've got this invisible ghost NPC using the default cosmetic, and it's following the player around, but it's invisible. Next, we'll make our monster mesh appear in its place. So here's the magic. This new function that runs continuously, we move our empty blueprint prop, which is, well, it's not empty anymore because it has our monster mesh in it, right on top of the invisible NPC, matching location and rotation. And we use move2 on our creative prop, which is just an animation of a monster running, so it can match the location of the NPC. Finally, the 0.0 sleep, it means it updates every frame, so the monster is perfectly in sync with our invisible NPC using nav mesh. And that's it. The invisible NPC handles navigation, and our monster mesh, well, it just follows along like it's the one that's actually moving. So let's test it in game. We've got our NPC spawner with the behavior script, we've got our hidden monster prop ready to go, and the NPC runs, but it's invisible, and instead, our monster minifig appears. It's running right towards us, claws out, ready to help us out into battle. Magic, right? Now, our monster looks alive, but it's just a skeletal mesh riding on top of an invisible NPC. Now, you can take this a lot further and add a state machine to check when the NPC stops moving, and then play an idle animation, for example, or attach a mutator to detect when it's ready, and even an audio player with some custom eerie sounds. The possibilities are endless. This trick, well, it pretty much lets you bypass the UEFN cosmetic restrictions. So to the epic folks in the back, I am only 10% sorry. And well, that's it for our technical deep dive. But before we close down, I want to circle back to what I said at the beginning about the cinematic part of game development. So let's talk a little bit more about the monolith cinematic in LEGO Dark Space. Of course, we mentioned how these make a really good first impression, but because they set the mood, right? They draw players in, but they're also a really powerful way to tie up a storyline. In this case, revealing which YouTuber, CypherPK, Lachlan, Loserfruit, or Ali A, gets trapped from the monolith strap. So to make this cinematic, we started with a very clear vision. So we began with a storyboard to map out exactly what we wanted. So you can see here a short example of just how we mapped it out. With that vision, we got to work in UEFN. First, we built the room in our map with the monolith at the very center, using the LEGO Dark Space, using the LEGO Space Gallery, assets that are available for everybody with this really eerie vibe, a little bit of